All right. I thought I would do something a little different this time and talk about something that is kind of close to programming, but not actually programming itself, but I consider to be pretty important, especially if some of you guys have any interest in going into programming as a career or becoming a professional software engineer. Knowing the latest, or I should just say the current source control and source management tools is pretty critical. And even for hobbyists, now that I've learned Git, I could never go back to not using it. Like when I was a hobbyist, when I was growing up and making games for fun, I would have killed to have this kind of tooling. So in light of, by the time this video is uploaded, I will have passed 10,000 subscribers. So kind of in light of that, I figured I'd do something a little bit different. And if you guys like this kind of stuff, especially things around software engineering as a career, let me know, and I'll try to do more of it when I get the time. Yeah, let's get started. So it's kind of a really stupid question, but why would you want to use Git? Just a couple notes. Ways I find it useful. One is it's good for high frequency project backups. So if you got nothing else out of Git, it just helps keep your code backed up at a very often frequency. Like when you're working on your code, you're backing it up almost every time you hit a milestone just by design by using Git, which is pretty useful if your computer was to crash or you spill water on your MacBook or freaking PC or laptop or something. That would suck. It's a good way to kind of have like a scratch pad for code ideas. You can take your code and work on it on some crazy idea you had, and then maybe a couple hours or a day later you decide you don't want to do that idea anymore. You can go back as if you never had that idea but still preserve it, if that makes any sense. It's really good for code and project organization. So if you have large projects or a project that's worked on by multiple people on like a software team, Git starts to become almost necessary to not get completely disorganized and lost. I mean, this is a no-brainer, right? Like nobody freaking doesn't use some kind of source control nowadays. And this was just what I was saying, it's the current standard for professionals. So this is all true, obviously, if it's used properly. So towards the end of this video, I'm going to go into some of the pitfalls and things that can go wrong when you're using Git, because that definitely is important. So I encourage you guys, if you're a newbie, which you might be by clicking into this video, to definitely heed some of that advice towards the end so you don't get yourself in trouble, because with great power comes great responsibility, I guess. So let's just kind of have a couple slides that give like to go through a visualization of how I see how Git works. So the way it works, you might have a folder, right? And your folder has your project in it and all your little files corresponding to whatever your software project is. And you can think of that folder today as a point in time of the state that your project is in right now. And as you work on your project over time, you might modify or save changes to certain files within your project, and they might only be a couple changes to a couple files, per hour or per day or something like that. What Git basically does is takes just the changes between two states of your project and puts those in a change set and preserves the differential or the difference between where you were and where you are, and puts that in something that's called a change set or a commit. So you can think of a commit as a point in time preserving the state of your project at any given point when you decide. When you make a commit, you're basically preserving the entire project. A good way to think of it is you're preserving the way the entire project was at that state and time for all the files that you've asked Git to track. So that's what a commit is. That's probably the most basic fundamental bounding block of how Git works, is it's all based off of these commits. So that's one commit. Now, as you work on your project over time, if you're using Git, you will be making multiple commits over time. And you will basically form this timeline of your project history. You control when you make the commits, and usually you do it when you hit milestones, or maybe you're at the end of a working day or a couple hours. You did something that you set out to do for that period of time. You'll commit your work and you'll type what you did. and you form this timeline. Git calls these timelines branches, and I'll come back to that keyword branch later, and it'll make sense why it's called a branch as we move forward. But for now, just think of a single timeline as a specific branch in Git. Now, one of the fundamental things about how Git works, you basically have a local branch, which is the way the repository, the Git repository, is on your computer at that time. And then you have a remote branch, which is a mirror of your entire branch on a remote server, which is just called the remote. So as you make work locally, you can synchronize that work by pushing it to a remote branch. In other words, you have a local branch and you're making a copy of that branch and backing it up, which isn't really what people would say, but you're pushing it to the remote branch. And when you do that, you update the remote branch to be a perfect mirror of the local branch each time you push it. So the way Git works is you make your commits locally, and nothing goes to the server until you push. And once you push, you've basically taken your local branch and you've now pushed it to a server where you yourself or anyone can access it from anywhere in the world. Now I'm going to go over something that's a little bit interesting. Right now we've talked about one computer with a local branch and the server that's called the remote with one remote branch. Suppose you had a second computer, so I'm Mike over on the left and there's some guy named Jack. And let's suppose Mike pushed his changes on his current branch to the remote and the remote got those changes. And then if Jack wanted to get Mike's changes, he would then pull from the remote branch and update his local branch. Now, Mike, the server, the remote, and Jack all have the exact same synchronized state of all the code for that branch. This paradigm works really well if Mike is the one producing all the work and Jack just wants to read or pull Mike's latest changes into his local copy of Mike's branch. One of the things in Git is that branches are given names. Typically in Git, the branch that every repository starts with is called the master branch. It's created by default, I believe. And you're just on the master branch with one commit the minute you start, or I think you make an initial commit. So let's just say that we're on this master branch, right? If you want to create another branch, you branch off of the branch you're on. So let's say we're on master. So you can branch off of master and call that anything you want. And typically in software engineering, people will branch off of master, do the day-to-day work on a development branch. All right, so let's talk about this again. So you branch off of master, you've created develop. This is important to note that once you're on develop and you're working on develop, you're only making commits to the development branch. Any work that was done on master would now be branched off and essentially disjoint from that development branch. So master would continue on happily if commits were made to it, the same way develop would. And you can switch back and forth between those branches and the project state will completely change. You're basically jumping between these points in time or states of your repository based off of which branch you're on. And that's a common thing to do, to switch branches. So if I wanted to do some development work, I would switch to develop. If I wanted to go back to master, which typically has like the more stable changes, then I would jump back to master and so forth. This. Okay, so suppose you have two branches that were branched off. You got your develop branch, you got your master branch. When you are done with a branch, and you know that that work is essentially completed, and you want to bring that work back into the main branch that you branched from, you do what's called a merge. So this commit right here is a merge. You're basically saying you want to take the work that was done on develop, all of it, and bring it in one fell swoop back into the master branch you branched from. This is a merge, and this is one of the more complicated operations in Git, or it can be. But for now, I'm trying to keep it simple, and a lot of times it will be. So this is essentially what a merge is. And at this point, you can continue to work on develop if you wanted, or you can say that it's done and then create a new one later if you want to branch off. Okay. So now let's pretend that we've been working on develop for a while, and develop's been doing its own thing. and Mike and Jack both want to do work, but they don't want to step over each other. And let's say they're going to work on different parts of the application. Mike would create his branch and call it whatever he wants. We'll just call this Mike, and do work himself. And he's creating commits now that were originally branched off of develop, and now he's doing work that is off on his own branch. And Jack does the same. Now he has a branch and he's doing separate work in separate parts of the code base. So now we have a develop branch, a Mike branch, and a Jack branch. What happens when we want to bring this work back into the development branch and synchronize it? Well, we first would merge Mike's branch back into develop and create a merge for Mike's work. Then, to make sure that Jack was in sync with the latest work that was brought into develop, Jack would merge the development branch back into his branch so that he has the latest develop changes. And lastly, Jack will merge his branch into develop. And at this point, if Mike wanted to get the latest develop, he could do the same. Or if his work is done and he doesn't need that branch anymore, he can just get rid of it and make a new one later and branch off and develop again for some new feature. I know this is probably the most complicated slide, but it shows the end result here. If you just pretend that there is no other branches, this is what happened to develop. You have some commits that were above that were the current state. You have Mike's work in one merge commit, which is in now one timeline, which is the development branch. And then you have Jack's work, which is his merge commit, which now brings his work in. And if you look at just one branch at a time, which I find to be very helpful when you're first learning Git, it kind of helps you understand the linear timeline nature of the way Git works. Now, I know this was a lot of shit to throw at you if you've never seen Git before, but that's the benefit of having this in a video, because you guys don't have to worry. You can just watch it again or go back through it, and certain concepts will make more sense. Boom. Sometimes you're making these videos and you go back and you watch them when you're editing and you realize something you said didn't make as much sense as you wanted it to. I basically taught you guys like the more complicated way to handle this kind of merging process. When I talk about Jack merging develop back into his branch before he merges his work into the development branch, if Jack is done working on his code, he doesn't need to do that. He can just merge his blue work right into develop as soon as Mike's finished merging his in. And the reason why that's the case is they're all headed that way anyway. The only reason why Jack or Mike would want to merge develop back into one of their branches would be if they weren't done working on their branch yet and they intended to keep doing ongoing work. And they do that to make sure they're in sync with the latest develop. There are a whole bunch of topics about how to handle this process going forward. It's called Git process. I don't want to get too much into those right now, but just know that this stuff can get a little bit complicated when you have a number of people working on the same team. But assuming that both people or yourself, if you're the one managing the multiple branches, are working on separate parts of the code, then this probably won't come up and won't be an issue for you. So let's actually get in. As you know, this channel, I usually go into actual real world examples. So that's what we're going to do. We're going to create one of these things. I created a GitHub account just for this video that I'm probably never going to use again. And we're going to use it to do something.
What they did to my hand, man.
So I'm going to create a folder here and just call this, I don't know, a thingy. And this thingy is basically going to be our GitHub folder, or our root folder for the entire GitHub repository. So I'm going to create some things in here first, because it's probably the way a lot of you would be starting out. You can't really you can create a repository with nothing in it, but it actually doesn't matter what order you do this in, but I'm going to go ahead and create. So I've created this stupid basic program, just a Mac application that has some UI that pretty much does nothing. And I'm going to go ahead and make one more. Actually, I'm not going to do anything yet. This project as it stands basically just does this, right? So let's go ahead and create a Git repository with everything that I've done so far and literally just leave this or start a Git repository with just this. So this is the part where I talk about the fact that I am not big on using Git on the command line. It's just a personal preference of mine. It dates back to just the way I prefer to do things using GUIs. So I'm going to initialize the repository by typing git init period in here, and that's probably the only command line git thing I'm going to do. So I'm going to use a tool called SourceTree that I've been using for a couple of years now that I really like. SourceTree is a GUI that allows you to do Git-like things. It's simple enough to understand, and I've been using it on both the Mac and Windows side for a really long time now. So this allows us to explain what I'm doing and not get too tied up in the Git commands. You can look them up if you want to do things in the command line, but I prefer to work this way. So what I've done here, and let me kind of minimize some stuff so we can just look at the Git stuff. I've opened up my Git repository, and you can see there's no timeline here at all. And what we have here is what's called the working copy of the repository. So you'll notice in here that everything that's inside the repository folder is laid out here and shown with a question mark next to it. What this basically means is that Git is saying that all these files are untracked. It doesn't know anything about them yet. It doesn't know if I want to track these files and the state of them over time. I'm going to go ahead and put check marks to stage certain files that I know are important for my project to be committed into the first initial commit for the project. Files that I know that are not important, I'm going to go ahead and tell it to ignore. And then I'm going to commit the git ignore file, which is what has these paths that tell me I want to ignore them. So everything inside here is going to be added to the repository in the initial commit. And this is up here in the staging area. So if you type down here, it'll ask you to type a git commit message. You can type whatever you want in here, but I'm going to call this initial commit, which is the initial commit for our repository. And then I always hit Command Enter on the keyboard, but I'm going to click this button, commit. And I've just committed now to my local master branch, which has been created for me. You'll see there's a little timeline point here on the master branch, and I've done that. There's no talk of any remotes yet. We're going to set that up here in just a second. So now I'm going to continue to work on my project, and I'm going to make some really dumb rudimentary changes just to kind of show you guys how you can track changes made to your project. So I'm going to add some UI here. So as you can see, I've made some changes, namely adding this stupid button that prints out on the console when I press it. Nothing too spectacular here, nothing really to care about. It's just enough for me to demonstrate that I've done some amount of work. So as you can see here now, my repository state has changed in the sense that I've modified the working copy. So every single time you open up your repository and look in your status, if you've made some changes, you'll see those changes shown in your working copy. So what this is showing me here is since the last time I've committed, I've removed these two lines in red and added these lines in green. And what this allows me to do is just get an idea of kind of what I've changed and what could be committed. Now I can choose to stage just certain lines or the entire set. And for the sake of this video and not getting too complicated, I'm going to check this little checkbox which stages the entire amount of changes I've made to the whole file. And I can just basically say here that I added a button. And then I commit, and you'll see here now we have a second commit in the timeline. Now I know in my slides I went from top to bottom. It's from bottom to top in SourceTree because they want you to see everything when you scroll to the top. It's the same idea, and that applies. So we've made a second commit now. Now my project is getting really awesome, so I think it's time that I push it to a remote repository because I want to make sure it can be pulled from other people that want to use it, or myself from another computer, which is a common thing that I do. So let's go ahead and go into GitHub and actually create the remote that we can push this repository, or push this branch to. It's better said that way. So we're going to go ahead and go into my GitHub here. and we're going to create a new repository, and we're going to call this thingy. I can't believe that's available. That's ridiculous. I'm actually not sure if these names are global or not. I'm going to make it private because I really don't need to subject the world to this dumb repository. And then I'm going to hit create. It's been done. This page basically tells me that the repository is entirely empty. And it's also telling me that I need to add the repository URL as a remote for my local repository so that I can push to it. It's even telling me exactly what commands I can write to do this. Now, I prefer to use yeah, I didn't even talk about authentication. GitHub makes sure that you're authorized to push to your repository. It would be really bad if people could read or write your private repository. So GitHub uses either HTTPS or SSH-based authentication to authenticate that you are who you say you are. We're going to prefer Git because I feel like it's just slightly more secure. And we're going to set up Git for this repository. Now there's a specific problem here, and that's that this is a brand new account, and I did this on purpose to show you guys how to set up GitHub. This particular GitHub repository has never been used by me before, which means I need to basically set up my authorization to use SSH to push. I'm going to go to SSH GPG keys, and I'm going to add an SSH key. And what this basically is going to be doing is it's going to allow me to insert my public SSH key. Basically cat out your key and copy it to the clipboard and insert it in here. If there's nothing in this file and you've never set up SSH before, you're going to have to run SSH keygen and enter in some fields on the terminal to get one of these. I'll leave that as an exercise to the watcher if that's something you want to do. But for now, I'm just going to go ahead and add my existing SSH key. Once it's in place, we basically can just copy this SSH URL and do a git remote add origin command and paste that in. And now that we've done that, we've set up our remote. We can go over here to SourceTree and refresh by hitting Control or Command R, and we can now push our master branch to the remote. So now that I've actually pushed my master branch to the remote, when I go over to my GitHub repository, you will actually see that everything that I've pushed into the repository now exists and is browsable from my GitHub repository online. I can look at the branches. Right now I have just master. I can look at the individual commits the same way I look at them in SourceTree, and I can see what's been added and removed with each commit, which is pretty cool. I also can actually browse the repository as if it was just a file system like on online cloud storage and look at the individual source code with source code files with syntax highlighting and all that fun stuff. It's one of the things that makes GitHub such a nice interface for doing this kind of stuff. Now you'll notice if I was to do some local work here and not push, obviously GitHub would not see that until I see any local branch stuff until it was pushed to the remote, for obvious reasons. So I think what I'm going to do now is really quickly demonstrate what a branch would look like for doing a feature. So I'm going to branch off of master, and I'm going to do some work that I think I'm going to, what am I going to do? I'll just add an image. So I'm just going to call this add image. And it'll be essentially a branch that's a feature branch that's going to contain the work that I need to do to add an image to my UI application. And on this branch, I'm basically going to do the work to add an image to the stupid user interface that we have for this program called Thingy. And then when that work is done, I'm going to commit it. So as you can see right now, this doesn't do much. It's just some text with a button. So let's add our image. All right, so let's just say that this is my stopping point for now and I'd like to commit. So what I'm going to do here is go to my staging copy. Notice that I'm on the separate branch than master now. It says that I'm on add image, which is currently tied with master. So all three of these branch heads are the same. The local master branch, the remote master branch, and add image are all at the same exact commit. But once I commit this work, you're going to see me add a new commit to my new branch. So what I got here is I got some new stuff that I've added that has already been staged for me by SourceTree, namely the banana image, and some stuff needed to make Xcode asset catalogs work. and then you see my code changes that I just made now. I'm going to go ahead and stage these. Initial work on image. And then I'm going to also check this special box, which will automatically push this commit to the remote branch, or to a remote branch. And once I do this, you'll see that we have it. And if I were to refresh my GitHub repository, you will now see that add image is another branch that can be selected, which has the work that I just did. I can go in here, I can browse. The work that I've done, and you can see it. So you'll now see that the branch has been added. Add image now has one commit, which is ahead of master. So and you'll notice this doesn't branch out because there hasn't, like in the actual graph diagram here, because I haven't actually done any work on master that is not also an add image. So SourceTree will kind of simplify the diagram of the branches unless there's actually branching work. So I'm going to go ahead and notice that I don't like this work the way it is right now, so I'm going to do one more commit to make the image not look like shit. I'm going to go ahead and commit this as well. So hopefully you guys are getting the hang of how this works so far. So now that I've essentially pushed this branch to the remote, if I wanted to go back to either this state of the code or to the master branch, I can do that just by double clicking. And the minute I've done that, you'll see that I've switched back to this point in time where I hadn't added the image yet. And if I essentially reopen this project, or rerun this preview generator here, you'll see the image has disappeared. And it is not anywhere to be found in the actual project structure anymore because I've jumped back to a branch that doesn't have that work yet. So that's one of the benefits of Git, is that you can kind of switch between multiple ideas. So what we're going to do now, kind of a final thing, is we're going to actually go back to master and do a separate branch to add a completely different feature to the application. So I'm going to go ahead and call this add title, which is going to put a title essentially in the top of the UI. Notice this is a separate branch from both master and add image. I verified that we are on the add title branch, and we are ready to work. All right, that looks good to me. So we created a title, we got some content in the middle, and then down the road, we hopefully will have the image when we're done. So I've added the thingy title. In real life, in practice, what we will end up having is obviously a lot more than just, a couple lines of code per commit. I'm simplifying what would be a much more complicated software engineering process, right? So add title. This will create a remote branch. You'll now see that we do see a branching in the visualization of our current Git structure, because we now basically have the master branch, a branch off of work that was done to add image, and then another branch from master to add the title. Now this is where things get a little bit interesting. We would like to essentially merge this work back into our master branch and have everything in one place. You'll notice I intentionally put the title up here, and I intentionally modified the image to be added in the bottom, and I did that for a very important reason, which I'm probably going to go into at the end of this video. So let's go ahead and show you guys how to merge. So first things first, I'm going to jump back to master, and I'm going to go ahead and click merge, and I'm going to select the branch that I'd like to merge into master. Let's go ahead and add the image first. If everything went well, you'll see that master is now tied with the head of the add image branch, which basically means that it merged this work back into master. I'm going to go ahead and push the fact that I've done that. And now the add image work essentially has just been brought into master. If I was to refresh our repository, go to the master branch in the remote, you will see that the banana is here, and so is the code to add it to the UI. So that's one merge. Let's go ahead and merge the second feature into master as well. So we're in master already. We're going to hit merge. We're going to hit here. We're going to add it. And you see the actual code has been merged back into one spot, which is master, and we're going to push. So one thing I'd like to talk about is a scenario where two users might be working on different parts of the code in the exact same place in different branches. When you try to merge that code together, you're going to get what's called a conflict. So I'm going to walk you through how that scenario looks and how to recover from it by resolving the conflicts. So what we're going to do here is they're going to pretend that there was a third branch made off of master that did some more work to the bottom of the code, essentially the same place where I added the image code at the bottom of this VStack. So I'm going to create a branch here and just call this more text or whatever. And I'm going to create at the bottom of this some footer text. And just for the hell of it, I'll even do that style, change some of the code up there as well. Whatever, I'm still learning Swift UI. Okay, so we're going to do that, right? We're going to create a branch, which we've already done, and we're going to commit this work, just the code changes, to a new branch here. And just for the sake of argument, I'm not going to push this one. So now we see that we've got more text, add title, and add image. Let's see what happens if I try to merge both add image and then the more text work into the master branch. So first I'm going to merge in the add image work as I did before. All right, now you see master has add image merged into it as I did before. Now we're going to merge in more text. Now this is what I wanted to show you guys. It's telling me there's a merge conflict because I've essentially modified pieces of the same file from two branches at the same time, and Git does not know how to resolve that. So what it's basically done here is taken my text file, created two sections of code to tell me this is what was here in master, and this is what that changes that were made at the exact same code in the branch you're trying to move in. And it basically tells me it doesn't know what order to put this text in. Now to resolve this, it's pretty simple. A lot of people prefer to use like special tools and things like that. I just prefer to read the text as I see it. And it takes a while to get the hang of this, but it's enough for me to know that I basically just want to do this and then decide which order these resultant things should go. And this is the order that I actually desire here. I'm going to go ahead and fire up the preview to make it look the way I want it to. And we see we have the title, or we have the text, the button, the image, and then the footer text underneath. Now that I'm certain this is the way I'd like it to look, I'm going to go into my working copy. I'm going to go ahead and notice that this thing was conflicted. I'm going to make sure that the code builds, which doesn't hurt to do. I've basically cleaned up all the conflicts. This is going to be the end result. I'm going to check this to stage it, and then I'm going to go ahead and commit this, and that completes the merge. And you'll see now that I have merged that branch back into master and resolves the conflict. And SourceTree will automatically tell you which file is conflicted when it creates the merge commit log for you. And it lets you know that a conflict occurred and was resolved. And just for the sake of argument, now I'm going to merge the title in to master as well. And we have all that work has now been in one place. We resume, we're going to have the title, the button, the image, and the footer text. And everything is exactly the way, if this was what I was aiming to do, make this stupid looking thing, that would be what I want, which is good. So I at least wanted to very briefly talk about some of the pitfalls with using Git. Git has a reputation to beginners that it's easy to make mistakes in that could end up destructive, meaning losing work. So I wanted to kind of dispel some of those things and give you guys some tips about how to avoid potential things that can go wrong. Obviously, this list is not exhaustive. I'm sure there's something in here I didn't cover, but these are some of the things that I can see people encountering when they're starting out. First things first is the word reset in Git is a dangerous word. If you're resetting something in Git, it means that you're essentially asking Git to erase those changes. If you're right-clicking a file in your working copy, meaning it hasn't been committed yet, and you're asking Git to reset that file, it's going to undo any of the work that you've done to that file since the last time you committed that file. So you can click on it, you can look at the changes that are proposed to be changed, whether they're staged or not. You'll lose those changes if you reset it. So you only want to do that if you're sure that's what you want to do. I think with all these points, when in doubt, ask someone, online, post on a forum, and stuff like that. Or what I would do is when I'm learning Git, I typically would back up my repository folder separately for the first couple weeks when I'm getting the hang of using it, if I'm ever worried. I mean, when in doubt, back up a file anyway. But yeah, in other words, when you're resetting a file, you need to know that you're losing those changes. The same thing goes with resetting branches. So while in Git, you can click between branches and commits for the most part without running into any trouble. If you right-click and ask it to reset a branch to a specific commit, you're essentially asking it to remove any commits that occurred after that point from the branch entirely. I typically will reset a branch when I'm certain that I either want to lose the commits above that, or I know there's a remote branch already that I can pull later. And earlier in the video, I showed you an example of what that would look like. So when you reset a branch, you should either have a remote copy of that branch that's further ahead that you can always go back to, or you need to understand that you're losing some of the work on that local branch as well. Okay, I'm gonna go forward. Deleting branches, that's obvious. It's just like a more destructive version of resetting a branch. It just resets all the commits from the branch, just deletes the branch. So if you're deleting a branch, obviously you need to know that you're not getting it back unless there's a remote copy of it that you can pull back. So that's another thing to be aware of. Switching branches is something that could be an issue. So if you're switching branches but you have a working copy, meaning you have changes you've made that have not been committed yet, certain Git programs will tell you and warn you you can't do that. And sometimes they will offer you to reset all of your working copy work so that you can switch. If you get frustrated or you're impatient and you just want to switch branches really quickly, you may not realize that by switching, you're resetting any work that you haven't committed yet that you might lose. So switching branches in Git should be done after you commit the work. There's another special thing in Git that I didn't talk about called stashing, which takes all your working copy and backs it up in this little place that you can apply later. I didn't go into that too much because I don't necessarily think that's a good practice to get into. But long story short is you should either know that you're losing your working copy or intentionally commit your working copy changes before switching a branch. If it's a file you really don't care about, you can also ignore that file as well, like I showed you early on. And the last thing, which is what we just talked about, was conflicts. If you have work that is being done to a file that is conflicting, this comes up obviously when you're working on teams. You and everybody else involved in that code that worked on it needs to get together and talk about how to resolve that conflict. And everybody needs to kind of sign off that the end result is what they wanted, so nothing got lost. So that's a quick appendix on what can go wrong. I felt like I at least needed to talk about it for sure. So hopefully that helps you guys understand a little bit about how Git works from a layman perspective. I've been using Git for a very long time. I'm just showing you guys some of the history of my own Verto Studio 3D modeling development. It goes back years, several crazy ideas and branches, and just me documenting my own work throughout, the HoloLens and the VR port and the initial iPad work and all that. It is very useful to be able to go back and look and see the changes I made if I ever were to introduce bugs or anything like that. What I'm getting at here is that even if you're the only one working on a project or not, Git is extremely valuable for software engineering on a large scale. If any of you guys watching ever wanted to do software engineering professionally, do it, for a career, it's just, as of today, Git is very necessary skill for doing that kind of work. I just think it's very valuable to learn it and to learn how to use it. So it's going to go a long way to practice using this if you want to do software engineering professionally. I hope you guys got a lot out of this video. I know I don't always explain things the best, especially when the topics are complicated. They always sound so good in my head, and then I try to get through them and I realize, like, shit, this is hard to explain. So I hope you guys enjoyed it. I really do appreciate 10,000 subscribers. That's awesome. I never asked for that. I never set out for that, and I'm not even really a YouTuber. At least I don't consider myself one. So that's really cool. But stay tuned for the next video, and as always, thanks.